Hello. In this video, I wanted to speak of the variants of the L-range model that are available. And here I am speaking of the L-range model specifically. And so for each of the tools, G-range, L-range, AF-range, there are different versions that will be available. But we're not speaking of versions here. Those versions are where there are typos that are fixed or small improvements that are made in the code. But here I'm speaking of bigger picture ideas, how ecosystem services are represented in these models. And so it's really like this. For G-range, where the L-range modeling family started, there's basically one way of looking at the world. And so for G-range, there's the one offering, even though there are versions available. The same is true for AF-range, the application of L-range to all of Africa. It's a way of representing ecosystem services, incorporating herbivores, the kinds of things that are talked about in the corresponding video, but really it's one way of looking at the world. The same isn't true for L-range. L-range is the tool that we've modified the most to be able to join, for example, with other tools. And so here we have G-range as a starting point, and the main change to convert it to L-range, as I recall, it was some time ago, was to just change the area over which simulation occurred. And so G-range, because it is global, assumes that each map is going to be spanning from negative 90 degrees to positive 90 degrees and negative 180 degrees longitude to positive 180 degrees longitude. To create the localized version of L-range, I modified that. I had the tool read the area that was to be simulated from one of the spatial surfaces that are provided. And so that was the primary change that created the L-range model, and that's the one that's distributed on the website and the one that's distributed in GitHub, for example, as code. But we are going to be distributing other tools, and these are tools that have been modified to join with other tools, primarily agent-based modeling tools, to create this coupled perspective. And so I'll have another video on coupled systems modeling, but really we're speaking of changes that can occur to join L-range to other agent-based models or other tools. Not shown here, for example, is work that's ongoing where we're changing the L-range model so that it can more effectively join with the SWOT hydrology model. But here you see L-range modified to join with the Dakuma model. That is work that I've done. It's being released in a paper now. The detailed description of the changes that were made are available. And another is for Spiral. That's work from Dr. Rika Warrior on all of Kenya. And so these are different perspectives, different tools. For example, Dakuma is quite detailed. It has houses at specific locations on the landscape. These are pastoral households. Whereas Spiral it uses a 10-kilometer cell. And so the houses aren't as specific, for example. And that has implications when thinking about how livestock, for example, may respond to water sources, if that's necessary to represent. The last example is L-range joining with Andes, which is work from Melody Zaria. We're working on joining those tools and addressing management questions for an area of Huascarán National Park in Peru. And so as an example of this kind of work, we have changes to L-range to enable it to effectively join with the Dakuma model. And again, I'll address this process more formally in another video, but here we have, the video will be on coupled systems modeling. But here we have a suggestion of the variants that are available. That is, the different versions, different pathways of editing L-range to join with different tools. So here you can see, for example, L-range and Dakuma joined, and they're going to be running at the same time and sharing information each month. So they're passing information back and forth. And so L-range is passing these 8 biomass pools. For every cell on the landscape, it sends to Dakuma the amount of green herb leaf forage available, the dead herb leaf forage, green shrub leaves, the dead shrubs, fine shrub branches in case the animals want to nibble on those fine branches, and the same for trees. And so these 8 pools of biomass are sent to Dakuma. Then Dakuma reads that and has the people make decisions about where they would like to graze their animals based in part on that biomass availability and in part on other things that required editing in L-range as well. Things like availability of water, and information is passed to capture amount of snow, although not appropriate for Samburu where it was applied. We still incorporate snow in case it's used elsewhere. Slope could be of interest. Various layers that are passed from L-range to Dakuma to represent different ecosystem services. And then Dakuma passes back the distribution of livestock back to L-range. L-range reads that and represents grazing from that. And so, in short, what we have are a series of tools that are all L-range at the base, but they're edited in different ways. And it's likely that some will work for some people. Some may need custom modification to join with their own tool, but the programming is straightforward and we can help as we can and get the work done that needs to be done. So go ahead and reach out, and happy to help where we can.